In this video, we're going to talk about amplitude. The first definition that we need to understand before we talk about amplitude is midline. A midline is the horizontal line that passes exactly in the middle between the graph's maximum and minimum points. The amplitude is the vertical distance between the midline and one of the extreme points. For example, the line that I have in yellow is the distance between the midline and the maximum. The line that I have marked in blue is the distance between the midline and a minimum. The amplitude, remember, is a distance, and distance is always a positive number, so our amplitude is always going to be a positive number. Amplitude can be found by the formula maximum minus the minimum divided by 2. And this should make sense intuitively. Maximum minus the minimum would be the distance from as high as my graph goes to as low as my graph goes. And if I divide that by 2, then I have half the distance, which is my amplitude. In this equation that I have highlighted in yellow, the leading coefficient A will help me determine my amplitude. The amplitude is going to be the absolute value of A. Remember that amplitude is a distance, and distance has to be positive. Problem 1, what is the amplitude of the graph of y equals sine x? We're going to look at this problem two different ways. First of all, we're going to look at getting our answer from the equation, and the second way is by looking at the graph. Y equals sine x is the same thing as y equals 1 times sine x. There's an understood 1 in front of that sine x. So my amplitude would be the absolute value of 1, which is 1. I also could have used this formula, max minus min divided by 2, and I could figure out the maximum and minimum from my graph. Just plug my information in, evaluate to get the amplitude of 1. Remember that you cannot just look at the maximum to find the amplitude. On problem number 2, we're asked to determine the amplitude of each graph. Now the first graph, it is centered around the x-axis. The x-axis is a line of symmetry. The maximum is 3, the minimum is -3. So I can just look at this maximum and tell what my amplitude is, that it's going to be 3. This distance from the top of that mountain down to the midline, or the x-axis, is 3. So my amplitude is 3. I could also use my formula max minus min divided by 2. Now in my second graph, I have the same type of thing where my graph is centered around the x-axis. There's symmetry there. And my amplitude here is 0.5. My third graph is a little bit different. I do not have the midline being the x-axis, so I can't just look at the maximum value. I have to use my formula. Now, if you were to draw in the midline, then you can see that this amplitude is 2. From the top of the mountain down to the midline is 2 units. Now, my next couple of problems are going to go back to this equation that I have highlighted in yellows, the general form for the equation of a sine function, and the amplitude is the absolute value of A, the absolute value of my leading coefficient. So problem 3, the amplitude is the absolute value of A, in this case the absolute value of -8, which is +8. Problem B, the absolute value of A is going to be the absolute value of 4, which is 4. Problem 4, below is the graph of y equals sine x. Sketch the graph of y equals 1/4 sine x. What's going to happen with this graph is that my x-intercepts are going to stay the same. The maximum and minimum are only going to be 1/4 of my original function. And there you can see the graph of y equals 1/4 sine x. One thing I want to point out about your homework is that there are some homework problems that I really want you to try to figure out for yourself. So I don't have examples like those in class. I want you to look at your definitions and your graphs that we've talked about and take that knowledge and apply it in a little bit different situation to help you gain a little bit more understanding about how all of this stuff relates. And it's not that complicated, but if you have questions on it, then please do ask. But I want you to know when you get to homework and you get to a problem that says, well, she didn't do like a problem like that in class. Well, yeah, I purposely didn't do a problem like that in class because I want you to do a little bit of thinking on your own and see if you can come up with that answer yourself.